Jose Pozo reporting from OFC. I just stopped by the booth at Enlightra and they have a comb laser. Why did you bring a comb laser to OFC?
Well, this is simply the best multi-channel source that you can get for doing, let's say, high-capacity telecom and datacom. With our unique comb laser technology, it's capable of producing tens to hundreds of channels that are precisely spaced. So just by the physics, they never move in their spacing. So it's quite incredible compared to, let's say, banks of DFB lasers or other technologies.
What problem are you solving here for the companies in the datacom telecom business?
Sure. Right now, people are simply scaling up if they want more capacity by adding more DFB lasers. First it's 1, it's 2, it's 8, and 16. And how long can that go? Can you have 1,000 lasers on a chip? No, probably not. Or even hundreds? No. So with us, we can start with a single DFB laser and then produce tens to hundreds of high-quality channels from a single source. So it's really scalable in that sense.
What makes you different from other multispectral lasers?
Yeah, that's a good question. Another difference that we have is when we create these systems we might start with, for example, a DFB laser, which is not bad performance, but we can improve the performance by a factor of 1,000. So we can take a single laser and then generate basically tens to 100 lasers that are 1,000 times narrower in their line width. And also, again, their stability is amazing.
What trend have you seen in this show in terms of WDM that makes you excited for Enlitra's future?
Yeah, it's clear people are going to higher and higher data rates, but the modulators are not getting much faster, right? It's gone from 100 gigahertz to 200 gigahertz. It's been a long time. So what does that mean? They need more lasers, right? And that's where Enlightra can provide solutions. And next year they can't go to 400 gigahertz, but they're going to just have to do double the number of lasers and then quadruple. And again, that's not so sustainable, and that's where Enlightra can provide a solution.
So this is the spectrum of a comb laser. You have every spectral band, and I assume that there is no temperature dependent because while the whole spectrum shifts, the distance between the modes doesn't.
Exactly, it's super precise and stable.
So how can you modulate each line individually?
So there are some standard techniques. For example, if you have ring modulators, you can have one line with a bunch of ring modulators, and the ring modulators can simply, for example, if you had a bank of ring modulators like this, each one could be set to modulate a particular frequency. And so there you don't even necessarily have to demux them first. It can all be in a single line.
One last thing, this box is very big. When is it going to be smaller?
That is a very good question. So what you see here, right, customers want to feel something is heavy, right? So we made a heavy box, right? So they get value for their money. No, but in reality, what this is, it's empty boxes inside of empty boxes. Really, our core technology, you can see here. It's a tiny photonic chip. All right, it's very big on this screen, but in reality, this photonic chip is no bigger than the size of your fingernail. And this is a commercially available DFB laser. We put these together, connect it to a fiber, and that's really the size that we can get down to in the future. So I see no problem of putting this into, let's say, a QSFP package moving forward for, let's say, pluggable optics.
John, congratulations on what you're achieving.
Thank you.
The world is very bright for Enlightra. Thank you.